Hello everyone. So for me, a whole day has gone since the stopping of the last recording and the starting of this one, which is now. For you, it could be 5 minutes, but it was causing me a bit of anxiety over the last 24 hours because where we left it, we had basically we were allowing Node 11 in the topology to be able to communicate all the way to the switches. In a real world, you're never going to see that. So I made I made the executive decision to add a second cloud. So what we're going to do is the old Node 11 is now turned into the actual internet. And then I added a second cloud, which is going to be more of a WAN type connection. So we're going to go ahead and we're going to fix the way the routing was or is to be more real life, okay? And we're going to introduce MPLS at some point. I don't know if it's going to be this video or a couple videos down the road, but we will introduce that later. So let's just do a quick recap. So if we look at, and by the way, I labeled the floors as well. So, these devices reside on the first floor in Site A. These devices reside in the second floor in Site A and vice versa over here. So similar situation in Site B. So let's go ahead and let's just look at where we had left that internet router as well. If you recall, we had this ridiculous route that said if you want to reach the inside of Site A's network from the internet, go ahead and allow it and route it through this hop. So we don't want to do that, right? That's not feasible. It's a security issue. There's all kinds of things wrong with that. So what needs to happen is Router 1 essentially has to have NAT configured, Network Address Translation, or Port Address Translation. So it's essentially taking a private address and it's translating it to a public address so that it's routable over the internet. So that's what NAT does. It preserves the use of IP addresses as well, which is where PAT comes in. So Port Address Translation will take any communications that are coming from the devices behind the NAT boundary or on the inside of the NAT. It will translate it to a single public address or a pool, one of many public addresses, and it'll rely more on the source port to distinguish between the flows. So this PC wants to get to Google, it's going to use a random source port, okay? That might be different, or it's going to be different than the random source port on a different PC going to the same destination. So that's the concept behind NAT and PAT. So first things first, let's go ahead and let's just get rid of it. Well, before I get rid of it, we can see that if we ping, let's say, switch 2, right, it should work, okay? We don't want that to work, okay? That's a huge security flag, and this is just not a realistic situation. So let's go ahead and remove that route. Let's verify that it breaks the ping, which it does. Okay, good. So let's leave that there. Now on router 1, let's just do some homework items here. So we still have the default route, so let's attach a name to that. So let's say name INET, okay? And then let's give a name to this one. This is, let's just call it inside. Name inside, all right? So essentially this route here gets anything that is destined for an internet-based or a non-specific match in the routing table is going to follow this route, okay? It's just going to chuck those packets out to the internet, and then the internet service provider can figure it out from there. This route is a bit more specific. This says, hey, anything that's destined for R/22 on the inside of this site, we're going to chuck it over to switch 1. So that's fine. This is a bit more realistic at this point. So how do we configure the NAT to make the internet connectivity work, right? Still continue to work, but not allow the internet to communicate everything to us, okay? Beyond, so let me just recap too. So in a real life situation, this router here it's either going to have some kind of a firewall that sits in front of it, okay? Maybe this router is a firewall. Maybe it's got routing and firewall capabilities bundled into one. But the idea is that you want some kind of a security mechanism to protect you from the outside world, okay? And a lot of people do the same thing, even if it's a WAN connection. They still have a firewall or something, some kind of a security box that sits between them and the WAN, okay? That's kind of industry standard best practice. You want to secure your environment the best you can. So full disclaimer, we don't have a firewall in this lab environment. We're focused on routing and switching aspects of, end-to-end connectivity. So on router 1, there's 3 things we need to do. We need to define what's called our NAT outside address and our NAT inside address. So in our topology, E01 is going to face the outside, so that's going to be our NAT outside address. E00, or the sub interface for that matter, is going to be the NAT inside address because that's what's facing the inside down to switch 1. We have to create some kind of a mechanism to identify the traffic that we want to translate. So in this case, we're going to use an access control list or an ACL to do that. And then the third piece to the puzzle is we have to create one of Cisco IOS's longer commands to tie the interfaces to the access control list that we're using to identify the traffic. So with that being said, let's go ahead and do it. So we'll go into E01, okay? We're going to say IP NAT outside, all right? And what this is going to do is it's going to deem this interface as the outside address or the outside interface for NAT. And iOS makes behind the scenes, it makes another interface that we'll see. It's a virtual NAT interface. So it takes a little while because this is all software based, right? So let's just give it a second. Okay, so let's do the same thing for our sub interface. So we'll come into this guy and we'll say IP NAT inside. All right, and then let's go ahead and define our access control list. So we're gonna say access list. We're gonna use 100. Okay, so we're gonna do an extended access list here, and we're gonna say, let's just use context sensitive help so we can kind of walk through it together. So we want to permit. Okay, we want to permit. We want to permit IP, so any internet protocol. All right. We're going to go ahead and we're going to say source. So we're going to say 10, 1, 0, 0 slash, we got to use let's just do anything 10 dot. Let's just say 10, 0, 0, 0, and we'll say 0. We have to do a wildcard. So not the subnet, we got to do a wildcard. So 0, and then we kind of reverse it. So 0.255.255.255. And then we want to do any destination. So again, we're trying to go from our specific addresses, which are 10 dot, to anything on the internet. So we'll say any here. Okay. You can log it, right, if you want. You can basically log any matches that hit this this access list. For our purposes, we're just going to go ahead and we're just going to say enter. All right. So we've defined our we've defined our NAT interfaces outside and inside. We've defined who we want, which traffic we want to translate, which is the 10 dot. But now we have to tie the two together. And we didn't necessarily tell it what we're going to translate it to. So that's going to be done in the next command. So the next command is the long one, right? So we're going to say IP NAT. And we're going to say we want to do source address translation. So we want to say IP NAT source. So you can see we could have done this. We could have done this with a route map, or we could have done it with an access control list, which is what we did. So we're going to say IP NAT source list, and now it wants either the number of the access list or the name of the access list. So we used 100, okay? Now it wants either the pool or the interface. So a few minutes ago I said you can translate this to a single IP, or you can translate it to one of a couple IPs in a pool. So that's what the pool does. This is going to be for larger environments that have many thousands of users getting out to the internet over one firewall or one router. You're going to want to do a pool so you don't run out of random source ports, essentially. So in our case, we're going to say interface. And here, all it wants here is essentially the interface that we deemed as the outside interface for NAT. So in our case, it's E01. All right. Now, this is the difference between NAT and PAT right here. So we could hit enter right here. Okay. If we hit enter, we've essentially configured NAT, or network address translation. However, if we put a keyword in here, which they call overload, Cisco IOS refers to overload, this is going to configure port address translation. So what this is going to do in English is it's going to say we want to NAT everything in the source ACL 100 out interface E01, and we want to overload it or use the source random source port to determine or keep track of that flow. So at this point, we're going to say enter. All right. And a quick, this isn't really a verification, but I usually do show run include NAT, and this is a good kind of way to kind of say, okay, I didn't miss anything. I've got the inside, I've got the outside, and I've got the command that ties the two together. And then obviously you're going to want to verify if the access control list is defined. Sometimes you can use a named list and name it something that has NAT in it. So when you run this command, you can actually see all four pieces in the config. But either way. So with any luck, so let's just go back to the internet, right? So it shouldn't have changed any behavior as far as the pings to the internal side of our network. So we still can't ping the switches, right? Which is what we want, okay? So there's no connectivity there. However, if we go to, let's say, PC2, and we ping the internet, I do have to check something here. Hold on. Okay, so we still have the route for switch 1. This guy should have that same route. Okay, which he does. Did I, let me see something. Show IP interface brief. Yep, 888's there. So router 1, ping 8888. Okay, we can ping him. Alright, let's go to switch 1. Why can't he ping? Oh, I know what I did wrong. I know what I did. So this command, it's not long enough. It needs to be longer, right? So let's go ahead and get rid of this. I missed a keyword here. So it should be IPNAT inside source. I think I mentioned that, and I just didn't put it in there. IPNAT inside source list 100 go out interface ETH0/1 and go ahead and overload it. Okay, so we missed, or I missed the inside command, which was telling it, you know, where are we natting from. So let's try that one more time. Hey, that's a lot better, right? So now we can ping 8888. So again, it should not have changed, just to kind of keep me honest. The internet still can't reach us, which is what we want, but we can reach the internet, okay? So if we go to the PC and we ping, okay, we've got full connectivity to the internet. So that's what we want. It's almost like a one-way conversation kind of thing, where it allows us out, but it doesn't allow things in, okay? So let's check show IP NAT translations. That's better. So now what we can see is we can see that, okay, we see that, for instance, 10.10.11, which is switch 1, it pinged 8888, and you can see it's keeping track of the translated addresses, okay? So it's translating that 10.10.11 into 200.0.1.2, which is the outside interface of our router, okay? So it's doing exactly what we asked it to. So switch 2, okay, it's using random source ports, as we see, and we can see that it was translated to the same IP. So remember, this is the key piece here. So 200.0.1.2 is that outside interface of router 1, and all these flows are using that same IP address, but it's randomizing the source ports, which is exactly what we wanted to do. So this allows us to have many PCs, devices, phones, whatever they are, right? Many devices connected and getting out to the internet, but doing it through the use of one single IP address, okay? So this is more realistic. I feel a lot better knowing that I've now demonstrated more of a realistic topology and flow, and I can sleep much better tonight as I did last night. So I think we're at a good spot to pause or stop, and we'll pick back up on the next one. Thanks, guys.